We've done that here to show that A is cosine alpha times I minus sine alpha times J, and that's using these two components. The cosine is the x value and minus the sine, because it's down below the axis, is the y component, and the same we do with the unit vector B. Okay, so that's the setup of the new coordinate system. Now the challenge becomes to find a representation of a given vector, V. The vector V is represented with the x component times the I unit vector plus the y component, this should be a y here, times the j component, and we want to find them, this representation, in terms of the rotated unit vectors A and B. In other words, we want to describe V in terms of these two unit vectors, not in terms of I and j. So V is some arbitrary or given vector sitting out here in space, and we can describe it with respect to x, y, or we can drop perpendiculars onto the A and B axes and describe it with respect to them. And the question is, what is the representation of vector V in terms of unit vector A and unit vector B? What goes into the parentheses? And there's a hint, which is you need to think about how to use the dot products in order to find components of vectors. This is the component of V with respect to A, or in the direction of A, or the unit vector A, and this is the component of V in the direction of unit vector B. And I'm not going to give you any more hints. I'd like you to go into your groups and spend a few minutes thinking about this and see if you can come up with the answers for what should go into the parentheses. And I will come back with the answer as soon as you're finished. So now I will reveal the answer to the challenge. If you want the component of V, this should be a vector, with respect to the unit vector A, you take the dot product of V with A and you divide it with the length of A. Well, A is a unit vector, so the length is going to be just 1. And the same, you take the dot product of the vector V with the B unit vector and divide it by the length of the unit vector, which is 1. So those two denominators are going to go away. They're going to become 1. And we can now work this out. We just have to take this dot product, V in terms of Vx and Vy, and with the dot product of A and B as represented here. And when you do that, you get this component for the unit vector A, the x component, or the A component, sorry, this is the A component, not the x component, and this is the B component in terms of unit vector B. Okay, now we're going to apply this to the question of polarized light, so get ready for that.